Hello, everybody. Well, good morning, good afternoon, good evening, good night to everyone across our lovely serverless world, wherever you may be. Thanks for joining us live here today, once again for Serverless Office Hours. We are streaming on the Twitch channel AWS and also on YouTube AWS events. I'm Julian Wood. I'm a developer advocate here for Serverless at AWS, and I'm joined by two of our proper superstars. First up, Shridar Pandey. Shridar's a PM who's a product manager who's been on Serverless Office Hours before. Shridar, for people who don't know, what do you do at AWS and how come you're on Serverless Office Hours today?
Thanks, Julian. Good morning, good afternoon, good evening to our viewers. I'm a PM on the Lambda team, and I lead a bunch of different things here, including developer experience, observability, and our integrations with third-party tooling.
So not big things, really.
Sorry, go ahead.
No, I was just saying, not really big things or important things. So yeah, I love the focus on developer. I love the focus on developer experience and observability. Yeah, so Shridar is the product manager who's making a lot of the magic happening that you interface with. Sure, behind the scenes, amazing product managers and engineering teams are also looking, how Lambda runs behind the scenes to make it faster and cheaper and all that kind of things. But a lot of ways that developers interact with Lambda is through what Shridar's working on. So yeah, we love the work Shridar's doing, and there's plenty more to come. Cool. And then also we've got Harold, and Harold's got an interesting story because Harold's been on Office Hours before. Harold's one of the absolute technical gurus who's been working on Lambda for many years. And even more excitingly, Harold's actually moved from China to work at AWS in Seattle. And yesterday was his first day. So second day, baptism by fire. He's straight into Serverless Office Hours. Welcome back, Harold. Yeah, for people who haven't heard of what you do, yeah, explain your I suppose your new role in Lambda now.
Yeah, thank you for having me here, and I'm really excited to join Lambda team so that I can work more on the Lambda developer experience. So yeah, that's
yeah, well, fantastic. I mean, for people who've seen Harold's done blog posts before, and he's done talks, and he's done Office Hours before. So Harold is properly in the weeds and a good engineer. So yeah, we've certainly got things to talk about today. So sort of Shridar, over to you. I hinted briefly, the kind of product management work you're doing, but holistically, how do we think about Lambda and developer experience? And we're talking about remote debugging today, which is the sort of highlight of a recent announcement. But yeah, just paint a bit of the bigger picture of how you think about developer experience and the space.
Thank you. Yeah. So broadly, we think of or we define developer experience as the collection of actions that a developer needs to take in order to develop, test, and debug code in order to solve a problem and then productionize that solution. And there are several factors that influence developer experience and as they proceed building on serverless or any service for that matter, but particularly in context of serverless. One of the first factors is ease of use, which is how intuitive and straightforward it is to use a tool or technology. Then the next is the time and effort it requires to become proficient in that, also known as the learning curve. How quickly and easily developers can get started and become productive, also the onboarding process. The coherence and predictability of the development environment, the consistency, meaning when you're jumping across from one tool to another, are you able to, get more or less the same experience? Sure, the different tools are meant for different purposes, but there should be some common thread across all of those. And also how well the tools work with other parts of the development ecosystem, commonly otherwise known as integrations or integration ecosystem. So those are in my view some of the key factors that influence developer experience, particularly when you're building on serverless. And serverless developer experience spans, a bunch of touch points and tools across the application lifecycle. There's the console, there is the IAC tooling, and tools for local development, such as SAM for SAM, CDK, and others for IAC, infrastructure as code, local development, SAM CLI. You could be using some IDE, such as the VS Code IDE. Some of that we'll touch upon later in this discussion. And each of those serve distinct purposes and distinct jobs to be done. So yeah, briefly, that's how we think about developer experience and what are some of the factors that influence it.
I mean, one of the hard questions I've always thought to ask is, one of the cool things about Lambda is that it is slightly different because it has amazing scaling and security and isolation and all that things. So Lambda is a slightly different compute primitive, and that's a positive in some ways, but also it's a negative in some ways because it's different from what other tool chains and different how other people do other kind of things. So in your mind, how do you sort of square those things where you can help Lambda be great at what it's good at and sort of bridge the gap with how people do things currently? And I suppose I'm mainly also thinking that what are the kind of things that is helpful to bridge that gap the way people do things currently, but also some of the bad practices or maybe the old ways of doing things that also you want to do things better in a new sort of more native way in the cloud.
Yeah, I think that's a great call out. So Lambda being serverless does not necessarily means developers would want to do everything in one console or directly in the cloud. If you want to move fast, and this is what we've heard from a lot of developers, that they still want to work off of their local environments. It could be the ID, it could be local tooling. There's a bunch of things that what that does is it frees them up from having to hit against a bunch of services or any service for that matter that's deployed in cloud and move fast as if you're building in a contained environment, everything locally. And then when you're ready, you jump over to the cloud, or even in as you go between steps. But they don't want to be doing everything in something that's directly working off of cloud, like for example the console. So that is one of the fundamental differences, as you would see, compared to when you're working with a VM or the traditional software development, or even working off of, let's say, working on some containerized tech. You could have everything working and have the entire dev lifecycle, the dev lifecycle workflow set up on local environment, and once you're ready, you send it over the fence and through to the CI/CD pipeline. That's a little bit different with serverless frameworks, and that's where our focus has been. So if you have a moment, I would break this down into sort of two fundamental parts. Like and these are not terms we're inventing here. These are well known, but I would like to emphasize on that a little bit. So think of that as two different, distinct but connected loops: the inner loop and the outer loop, also known as the inner developer loop and the outer developer loop. And inner loop is where developers spend most of their time on their local development environment. This is all about rapid iteration. Write code, test locally, debug, repeat, and so on. There you can use tools like AWS SAM CLI and various IDE integrations that make it possible. The key fact with the key thing to remember with local inner loop is that developers want to know if their code works in seconds, not minutes, and it's all about immediate feedback. Whereas with outer loop, this is where the code goes from a developer's machine to production. This involves things like CI/CD pipelines, security checks, various collaborative workflows. Here you could have services like code pipeline, various monitoring services, security services, and so on. And we've tried to balance both, but there have been a lot of investments in the outer loop, and this year we have sort of been focusing a lot, and this should be evident from the developer experience launches that we have had in this year, where we want to make it simple. We want developers to work with things, with environments, with tools they're familiar with, and move fast.
Awesome. Before we carry on, I just want to, obviously, live on Serverless Office Hours. If you are watching this tomorrow or the next few days, it's great. You're still going to get all the information. But yeah, if you're live, please send us a message where you're from in the chat. Can't quite bring up the chat so easily myself today as well. But we've got Joe Eliota from AWS who says, congratulations, Harold. There we go. We've got an amazing producer, Jeffrey, behind the scenes, who's making more of the magic happen today. So I appreciate Jeffrey. We've also got R. Darrell IR. He says from Ottawa. More support for debugging Lambda from AWS, so he's super happy. We've got some people saying Shridar's background is blurry, and is it somebody with these glasses? I've got the glasses on. In fact, all three of us have glasses on today, so nothing happened. But yeah, but Alu Kardanson, apologize if I butchered your name, but yeah, thanks for joining us via Twitch. And our friend, schizophrenic web developer, who joins us on numerous office hours, is also correcting who's got the blurry backgrounds. But just sort of Thank you. So yeah, let us know where you are. We've got an amazing global serverless audience. Let us know where you're from. We always love to know where you're from. So we're talking about debugging today, but there also have been some other sort of recent launches. So yeah, Shridar, do you just want to quickly chat about some other kind of things, because this is all a bigger story. It's not just individual launches.
Right. Yeah. So like I mentioned, 2025, and it actually kicked off before 2025, but let's just focus on 2025 for a second, right? 2025 has been all about making the local development experience, the IDE experience, amazing. Let me walk you through some of our biggest launches. Again, this is not exhaustive, but these are some of the key ones I want to call out. So we started the year with a guided walkthrough experience in VS Code IDE. The goal here was to make it easier for developers to install the necessary tools that are required to locally develop, test, and debug and deploy their applications. So think of Docker, think of SAM CLI, and so on. We got all of those in. This came out in January. Then in March, we had two key features launch. The first one was serverless LAN patterns, which brought out serverless LAN's extensive application pattern library directly into VS Code IDE. So now you could browse them, install them, and use them directly from the IDE without having to leave your environment. And Julian was a key advocate for it, and he was extremely involved throughout the process. And then we also had Livetail for real-time logs integration in IDE. So now you could, if you remember, we had launched Livetail, CloudWatch Livetail in the console last year around October timeframe. We brought that same experience to the IDE as well. So again, making the consistency part of the factors that influence developer experience that I talked about earlier, right? We're bringing more and more parity, more and more consistency. Then in April, we introduced support for custom domain names for private REST APIs if you're using API Gateway in SAM. This was directly motivated by, first we launched this capability in API Gateway last year, and we had heard from customers that they wanted this in AWS SAM, so we launched that then. And then in July, we had two major launches. We are going to focus a lot on these two in the rest of the segment. So the first one was the console to IDE integration, which enabled developers to easily transition from console to VS Code IDE in just one click. A key call out there is a special feature there that lets you just convert your application to SAM templates in just one click. The name of it's a simple button that's called Convert to SAM. And then the remote debugging, which I believe is the coolest thing we've done this year, in my opinion, which is the ability to remotely debug your functions running in the cloud from VS Code IDE. And this is something, this is a very novel thing. This does not truly exist in such a nice, seamless, packaged way. And so that's that. And last week, and I would round it off with what we launched last week, which was GitHub Actions for Lambda deployment. This is if you're if you use GitHub Actions previously, you had to do write CLI scripts, AWS CLI scripts, or or other mechanisms that require you to operate and maintain those. But now we've taken care of that. So now we just provided a AWS official AWS GitHub action for you to deploy your function. So anytime you make code or configuration changes, that would be that would already be pushed out to your AWS account. I would cap off at that.
Cool. I mean, that's a whole bunch of stuff. I know we can't really always talk about the futures, but I mean, we've only got a few friends listening over here, or maybe more than a few. But what should people be excited about? What kind of things looking forward are we at least looking at?
Yeah. So without going into the specifics, like you said, we cannot talk about talk about it much.
If only.
Yeah, but let me say that we are not done for the year. Let me just say that. So we still have a few things to come out between now and by the end of the year, and things that a lot of folks will be excited about. The only hint I would probably want to drop is that these are things a lot of you have asked us for a while, and so we have taken that to heart, and we are working on some of those, but and the other hint would be they are aimed at making a local development experience better and faster.
Cool. And yeah, just to reiterate that, I mean, literally the stuff we're building is based on your feedback. So, Shridar is talking and other people are talking to, yourself as developers and customers all the time to work out what you need. So please, Shridar loves it. Would love your feedback. I hope I'm not speaking on your behalf, Shridar, but,
Absolutely.
this is what we thrive on. So, things coming up or ideas for new things, or when something comes out and you want something more, or you have a different use case, let us know. It's cool. It's so cool when I see it, and I sort of see the circle forming where I've even spoken to someone, chatted internally, and it all happens, and in some time later, something comes out, and it's like, oh, that's so cool that it all comes. So we've got other people joining us. We've got Wadondera A. Collins, who's joining us on YouTube from Kenya. That is super cool. Thanks so much. Ardaroa says, well, pre-invent season awaits. Of course, reInvent. And I was going to have a slide up, which I should have done. reInvent's happening at the end of the year. Obviously our big show of the year. Certainly some exciting things the Serverless org and AWS and the Lambda team is working on specifically for that as well. So I'm sure pre-invent will have some cool announcements. And then, Peter Smith from New Zealand, happy to be remotely debugging from down under. And it's like 6:15 in the morning.
Hey, Peter.
So, Peter used to be another product manager. Exactly. So, great to always see you on office hours. And kudos for getting up this early in the morning to be with us. I mean, have we got some stuff to show? I think we've talked some kind of things. We have spoken about Lambda debugging before, and I know Harold's shown it before in office hours. There was some stuff to set up, and it was a bit harder, and now it's all just part of Lambda. Isn't that so cool? So I don't know, Harold, do you want to give an overview, or Shridar, do you want to give an overview of what you're talking about? You can see this is live. We haven't scripted it because I'm just throwing the question out there. And we see how we chat about it.
I can set it up for Harold, and Harold take it away from there.
Cool.
You know this really, really well. So I think one of the key things that we know we would, when we talk to developers, was the ability to sort of remotely debug. So the idea that sure there were we supported local debugging through same CLI and VS Code previously, but there are certain things that the classic does not worked on my machine paradigm, where things were working hunky dory, and then you sort of sent it over, deployed on cloud, and golly gee, things stopped working. So to address that problem, think of scenarios where you have a bunch of IAM permissions, or some specific IAM permissions configured, or your functions attached to VPC. Those things are very hard to emulate locally, there were solutions, but those solutions required you to take on some work, like Julian alluded to, and we just wanted to make it super simple, extremely easy to configure, or not even configure, just get started. And that's what the team has done, and Harold has been closely involved with this effort as well. So with that, there are a bunch of cool things. I would rather stop talking and have Harold show what we're talking about here.
Sure.
Cool, Harold, do you need to share your screen yet, or you want to chat first? It's a bit remote hands here, so
I can
let us know when you want us to bring up your screen.
Sure. So before I show the demo, I think we can talk a little bit about the history of how we arrived to this solution for remote debugging. So during the last 10 years for Lambda, there's many attempts to create a good solution for remote debugging. There's numerous people who tried it in both internal of AWS or outside. There was some solutions that kind of work, but need some setup, like deploy some infrastructure in the customer accounts, and set up and tear down. That there's a lot of work to do. We think we can have a better solution that is much simpler, without the need to deploy extra infrastructure in the customer accounts, and we can have a very smooth, like one-click experience to set up the debugging. That's what we have finally arrived, is to use IoT security tunneling to set up a secure tunnel between the ephemeral Lambda execution environment and the local developer's laptop. And we have incorporated all the setup and teardown logic inside the Vescal extension. And we have another secure tunnel that layer attached to the function. They can establish that tunnel and allows a local debugger running in the VS Code to connect to the remote function running in the cloud and do the debugging. So that's the basic overview of the history. So now I think we can go to the console and share my screen, and I can show you the two features that we wanted to share. Can you see my screen now?
Yes, we can. Thanks.
Okay, so this is Lambda console, and I have two functions. One is Node.js, one is Python. So let's see the first one. That's hello world, very simple Node.js function. It's actually just printing hello world from Lambda. This function, usually people start from building simple functions in the console. And what we have now is we can click this button and open this function inside VS Code. And so the function code will be automatically downloaded to your local environment and open in VS Code. You can do changes. Let's say you can change the code now, and the VS Code extension will detect that the code has changed and offer you an option to deploy it. So once the code is deployed, we can actually use the extension to invoke it remotely. So there is an option called remote invoke. We can invoke it, and you can see now the response is already updated with this one. And if we go back to the console and refresh the code, you should be able to see the code is also updated. So in this way, developers can quickly move their code from their function code from the console to the local environment, so that they can do more complex development, like adding dependencies and commit the code into a Git repo and that type of thing. But another thing we can do is we can use remote debugging to debug this code.
Harold, just before we get to the remote debugging,
yep,
because I think this is fascinating, that basically you've got something in the console, and before, it was like you needed to recreate your function to do it locally. And I mean, I've tried it before. I didn't even know more. I mean, I worked out where to start, but that was super hard to start because I've got to create a function. I've then got to use AWS CLI commands. I know how to zip it up, but you'd always get the folders incorrect and all this kind of thing. So what it's actually doing is it's literally pulling the function code from the Lambda service itself and populating it locally. But it's not just the function code. If I had a package.json or whatever, I could install a whole bunch of dependencies, and then that it would detect whatever's installed and then just package that up. It's basically zipping it up and sending it up to Lambda. Is that the case? That
yes,
so it's not just a function code. I can literally whatever I put in my function package will then get synced back up to Lambda.
Correct. Looking at another function, this function is a Python function, and it has a bunch of dependencies. So if I open this function locally using this one, it will actually download that, and with all the dependencies downloaded as well.
Yeah, so you could go into your requirements or text or manually do a pip install or UV or whatever, for node something, add another dependency, load it and up, and it would just detect that and update your function.
Yeah.
Correct. Yes.
And it does a diff as well, doesn't it? So it's not, is it packaging up everything, or is it, if you just then make a one-line function and you've got a whole bunch of dependencies, is there some cleverness we do there, or because it's all local, it doesn't really matter?
So I believe this is download the whole the code package that you deploy to the Lambda, then download all the things there.
But if you then had to re-zip and repackage it up, is that, if I did it 3 or 4 times, is it just doing the diff of my app.py, for example, or zipping the whole thing up? Or
well, the extension will do that update for you. So zipping up and those things, let's say.
So it just happens behind the scenes. Yeah, you don't really need to get.
You don't need to do that manually.
And the key thing probably is to sort of call out here is that you would, with console, you cannot have the dependency management piece, right? That's only available through the IDE. So that is, so if you now, and previously, just to do that, you would have to go through the steps that Julian described earlier. But now all you have to do is go to, even if you want to continue working on console, all you have to do is go to VS Code, add your dependencies, come back to the console, and go on from there. So even if you not actively want to work, even if you don't actively want to work on in the IDE, even then there is value in this for you.
Yeah, that is fantastic. Yeah, that's a great call out of you get certain way along the process and like, I just need a dependency because, in this example, I've got requests. You always need requests. And now you're like, I've got to start again and do all of that zipping around. Renato Valenzuela, who's awesome. Renato also works on the Lambda team, sort of says, of course, Lambda doesn't accept partial updates in the comments. Lambda doesn't accept partial updates. So the full zip file needs to be sent. Yeah, I understand that. I was just wondering whether the local zip file is just accepts diffs, and then it's obviously got to update the full zip to be sent. But yeah, I suppose that's just a nuance. R. Daryl IR also asked, the OS architecture ARM versus x86 will have to match, I suspect, between local and the Lambda environment. Correct me if I'm wrong, but I don't think that really matters at this stage, because what this is doing is just updating the actual code part of it. It's not really doing anything ARM or x86 locally, or it's not even doing anything with Lambda service itself, if you know what I mean. The Lambda configuration is just syncing the code.
Correct. They're not trying to run your function locally or some other infrastructure. The way your function runs still remains the same no matter where you invoke it from. So if you have x86 or ARM architecture, your function will still run on the same hardware or chipset that you selected. So regardless of where you're invoking it from,
because it's all remote. And then Brenny Cloud asks, is it a local copy or does it stay in sync between the environments? I presume if you do then upload it, make some more changes in the cloud, you need to click that button again to then sort of manually resync it locally.
And it detects it for you, right? So as you saw earlier when Harold showed it, he made some code changes and it automatically prompted him to deploy. So
if you make local code changes, but if you make cloud code changes, you just need to click on the button again.
Yes.
Yeah, to sync it back, then you need to put it back.
Okay, I mean that makes sense. One last question, because I know we want to get into the debugging. I know it's downloaded into Visual Studio Code, but also obviously currently, especially in this AI coding world, there are a lot of VS Code clones which have the AWS toolkit installed. So how does it work with those kind of things? Does the download only happen to VS Code, but you can use the toolkit in any VS Code clone, even Cursor and Kiro and all these other kind of things in Windsurf? You can still use the AWS toolkit to manage your resources and in fact do the remote debugging, do the remote invoke and all this kind of thing. But is the actual download into VS Code, because that's obviously a hook available within VS Code itself. Is that correct, or have I missed something?
No, that's correct. I mean this would work with Kiro, for example, as well. I think the demo that Eric recorded, I can't remember it was for remote debugging or was it for this. And Eric shared a demo video that was that used Kiro. I believe it was for this, yeah.
Because that'll definitely work for the remote debugging. I just wasn't sure for the console, this taking the console stuff and bringing it into IDE. But I suppose my bigger point is like a lot of the stuff, if you've moved to another coding environment and you're like, is this really important to me for VS Code? If you have the AWS toolkit for Visual Studio Code, you get a lot of the stuff also built in wherever your VS Studio Code is running as well.
Yes, that's the point to take home. Yes.
Okay, cool, excellent. So yeah, Harold, a slight sidebar, but let's get back to the remote debugging.
Sure. So let's see. We have using console to local to download this function locally. This is actually in a temporary directory. You can see here.
Okay,
yeah. Temp. So but we can still use remote invoke and check this box to do remote debugging. But there is something very important that you should pay attention to, because remote debugging actually depends on the matching local root path and remote path. Remote path it's fixed. It's var task. But for local root path is very important. One way to do it, if you have the code already, you can browse the directory to find the code directory and set it. This is one way, or you can use this one to let it automatically download and select the folder to let it store the code into your local computer. With this one configured and select this, we can set a breakpoint. Let's say return here. Then let's do the remote invoke. So what it does is they will make some changes on the function to, let's say, add a layer and then make a few variable changes, then set up the IoT secure tunnel, and it starts the invoke, then send the invoke to it. You can see this invoke already stops at the breakpoint that we set. We can step through it. Of course, it steps into the Lambda runtime code. But anyway, you got an idea that we can stop it. Now let's do another invoke. And you can see the all the context, the data here. And also, you can also modify data here if you want. Another thing we can show you is, let's stop this debugging session for now. And let me make a little bit change here. Let's deploy this. Let's override that. I have updated the code again. This will force for the next invoke. It's gonna be code star, and I can put a breakpoint in the import statement. This will stop when the function code starts. So let's try again. Yeah. So you can see that this invoke actually stopped at the import statement. This is not in the handler function. This is a code start pass. Now let's resume it. It gets into the handler function. You can do the lot more handler debugging logic. If I do it remote invoke again, now this instance is warm, so it won't stop at the import because the code starts already over. Now you can do the normal debugging here. So that's amazing.
That is, so I think a lot of things to pull out there and reiterate. So yeah, we've seen local debugging before, whether you use SAM or whether you this is just whether it's Node or Python. This is Python. You can do debugging locally, make it look like it's Lambda or not even look like it's Lambda. But this is a Lambda function that is running actually in the cloud. It's maybe connected to your VPC or connected to your database or connected to your private endpoints or whatever. And there's no way you would have been able to do that. Well, it would be really hard to do that locally. I mean, it looks so fast and looks so quick that I think you forget that this is actually connecting to the live Lambda function that is running in the cloud. Yeah, and doing its thing. I think it's just it's worth teasing that out. That this is a live running Lambda function in the cloud. I mean, sort of blows your mind that that's even possible. And all the integrations with it's happen to just update the code as you're doing again. It's just syncing, doing its kind of thing, finds the breakpoints, off you go, and then able to do a cold start. So obviously, once the functions run once, the cold start is not available. That cold path wouldn't be there. But yeah, the first time you're going to do this configuration, it's going to be a cold start. And that actually, I didn't even think of that in my mind. That, hang on, we're actually able to set a debug checkpoint, a breakpoint, even before the handler starts. I'm like, that is cool. That is cool. Awesome.
Yeah. So I have made some changes on the code and redeploy the function. So let's do a remote invoke again. So remember, this will be a cold start. We can stop there and let it run. So it goes here, and I can step through. I get the IP address of the current Lambda sandbox. But you can see the value somewhere. Okay, but anyway, you will get the idea. You can get the IP address, right? So IP is here, and if you want, you can also change the code somewhere. Let's make additional changes. Let's move this message over, out. Let's do something like this. And put the value here. Let's deploy again. Oh, sorry, this is Python.
Harold's so good at so many languages. He's like, oh yeah, this is just another language. No problem. Let's just use the other part of that brain and switch over. True pro.
Yeah, sorry. So, no, do I invoke again? I think this might not be. Oh, got it.
And you can see what Harold is doing. It like making changes in real time, deploying, debugging, and it kind of it's hard to believe if you don't know that this is actually happening on a function that's running in the cloud. So this is not some local emulation of a function. I know Julian mentioned this again, but every time I see it, and despite having been involved with it for so long, it still boggles my mind.
It's sometimes when the demos are too short and too quick, and you're like, hang on, let's just slow down and show what's actually happening behind it. And this is literally ticking a box and then maybe configuring the local root path just so it can basically read the code locally, so it can sync that up. But I mean, that's a tick box.
So you can see here, the code is there. I can change the value and let it run. And now you can see the returned value is hello. It's not this one, because I can stop the code here and make changes to the variable and let it run. It actually use the updated variable value to return it. So it's pretty powerful for debugging.
Cool. Yeah, I want to dive deeper into some of the technical changes that happen to the Lambda function and when you turn it on and off. But let's just jump quickly to some of the questions. We've got Itish Sai, who's joining us via Twitch. Thanks so much for joining us. Is this possible for SAM TypeScript using ES build? So yeah, I mean, what runtimes does it work with? What Lambda functions that need different build steps. If you could just walk us through how this works and what would be the process for that.
So right now, Lambda remote debugging supports JavaScript, Python, Java, and for Java TypeScript or JavaScript with source maps. It's a little bit complicated. For source maps, if you are using SAM, so SAM CLI to build your function and deploy, it should work. If you have using other tools to build the source map, that right now it won't work, because we in the extension to do the remote debugging, like I said, we need to match the local root path to the remote local path. We have tested it and handled the SAM CLI's build directory. They have a very specific source map. Inside source map, there is a variable to say where the source code is, where the TypeScript files are. And if you use CDK to build your TypeScripts, that path is in something different, somewhere different than we expected. So that's something we need to follow up and support those.
Okay, so yeah, so schizophrenic web developer, partly answered. Thanks. I love it when people who are watching answer each other's questions to sort of tease us all out. But schizophrenic web developer said, so I guess that this debugger works after the code is deployed in Lambda, and before said converting, it's converting the TypeScript code to JavaScript before doing things. So that sort of makes sense. And so the debugger works after the code is deployed to Lambda. And so yes, if you've got the source map locally and remotely, the extension can sort of figure out from the source map where you are, but obviously there's a bit of a compatibility matrix to make sure that'll work. So I think that makes sense. So yeah, then AJ Atnik, sorry for messing up your name, 2006, also joining us from Twitch. Thanks for joining. Where can we see the debugging layer? Does it make a local copy somewhere? Does it get detached once we stop debugging? So we can't see it locally. I will get into a bit of the technical details technical details of what actually gets changed in your function shortly, because I do have that question. There's another one I want to check. Oh, well, Chad Marie has also come up with a question. Is this compatible with containers and ECR?
No. Yeah, today we don't support, at least right now, we don't support functions packaged as container images. But thanks for the feedback. That is useful feedback. If there's interest in that,
cool.
that is something we will look at.
Cool. So we've got Node.js, Python, TypeScript, partly TypeScript, and then Java as well. So yeah, obviously compiled languages isn't going to work because it's compiled and you can't sort of stop in the middle of it. It won't kind of work. But yeah, Harold, you mentioned before that there's some changes that happen to the actual Lambda function when you click that checkbox and then you do the remote invoke. Can you just take us through what changes actually happen to the Lambda function with the obvious big important caveat? And I noticed it does say there, remote debugging is not recommended for production environments, because this is going to make changes to your production environment and to your function. By making some changes, and if you've got production traffic going through that, things may not work so nicely. So, this is obviously a big caveat saying, this is for development environments. You're testing something out. It's in the cloud. You want to test access to a database, something in your VPC, something that you can't emulate locally, or something you just want to really try in your live environment. This would be the way to do it.
Yes.
So, what are the changes that actually happen to your function?
Yes. So for when we check this remote debugging box and do the invoke, the extension, the VS Code extension, toolkit extension will make changes to your Lambda function. It will attach an additional remote debugging layer, and also modify your function's timeout to like maximum 15 minutes, allow you more time to debugging, and also add a few environment variables that used by the layer to connect to the tunnels and stuff. But the extension makes those changes. It will create new version that contains those changes, and the invoke will actually target that specific version. And once the debug session ends, or you manually tear it down, the VS Code extension will undo those changes. It will delete that version and restore the configs. Restore the configs. Actually, it will restore the configurations. Actually, right after the version is created, it will restore the function's timeout and remove those variables. That's what it does.
Yeah, I think it's a very important call out that we do not recommend it for production, but that does not mean that we are modifying the function that you deployed. Right? We create a new version. There's no such thing as temporary version, but think of it as a temporary version, which is the new function version. So this version, if you're using latest, this does not automatically become latest. This is just this is just a version that we create for us to enable remote debugging. And the reason for creating a separate version is so that your existing function does not get impacted in any way. So even if it is serving invokes, it will continue to. It will not be impacted in any way. And as soon as we are done, like Harold said, as soon as we are, when you stop debugging, as soon as you detach we go ahead and remove that, so it does not sit around. And the timeout, setting the timeout to 15 minutes is only for this version. So again, your debug session, if that, let's just say it lasts for a few minutes, that's the only time there will be an attached a temporary version attached to your created for your function. And as soon as you're done, that will be wiped out.
So what happens to $latest? Does $latest get routed to this normal version or not? How I'm trying to wrap my head around how that works.
So this one is we publish a version so that we can avoid impact on your normal version or alias. But if you are just in a debugging environment or testing environment that you don't care the impact because it's not serving the production traffic, so you could just uncheck this. We will not publish create a new version. You can do quick debugging on the latest. That's basically what it does. But the one caveat is if you do not select this, you need to be careful because the concurrency If you have concurrent requests coming to the latest, Lambda could have multiple execution environment and sandbox, but only one of them will be able to connect and debug. The other extensions will not be able to debug.
Yeah, so all the Lambda functions will be reconfigured. The new sandboxes will spin up. They'll all have the configuration, but they haven't got the IoT tunnel running, and so you've got a bit of a race condition where you don't really know what's coming to connect your actual Lambda function. So okay, that makes sense. So 3 changes to your Lambda function. A new version is published generally. It sets a timeout to 15 minutes, so that gives you time to debug. I presume if you haven't done your debugging in 15 minutes, well, it's gonna bomb out and disconnect, and you'll have to re-invoke it again to do that. I suppose that makes sense. And then technically, we are actually just adding a Lambda layer, and that Lambda layer includes an extension which has all the debugging code in it. But in a way, you don't need to worry about that. You don't need to think about it. It's just adding a Lambda layer and removing a Lambda layer afterwards. And then the other part we haven't sort of covered is behind the scenes, the magic all happens via a WebSockets connection. And I believe this is using, IoT Core, I think, or something. And so this is, managed WebSockets connection. Again, you don't need to think about that, but that is that debug port on 9229 that then allows the local debugger to use the WebSockets to then connect to the Lambda function via the extension. Is that a sort of top level, deep enough understanding of how it works?
Yeah, that's very close to what it works.
That's Harold's polite way of saying, no, Julian, you're wrong. Let me explain this properly.
No, you're not wrong.
Very kind of you, but
just one small detail here. In the IoT Core, there's several things. There's IoT Core MQTT broker, which is high-level MQTT broker, and you need to package methods, payloads in MQTT format. It's a PubSub broker that can publish message to a topic, and then you can subscribe it. What we are using here is not MQTT broker. We are using another feature in IoT. It is called secure tunneling. Secure tunneling is a feature that IoT provides for operators to debug remote IoT devices, which is hard to get access to. That service can actually establish bidirectional TCP tunnels, and it will automatically encapsulate and decapsulate the messages for you. So it's much better and a nicer way to do this, to use that to do the security tunneling. Because one difference is IoT MQTT broker is actually PubSub, and there is message size limits. That one message that published to the broker is limited to 256 kilobyte. And for Lambda function, the payload size could be very large, like maximum like 6 MB. If you got larger payloads and you wanted to send that payload via the MQTT broker, then you need to think about how to break that large payload into 556 kilobyte chunks, and you need to add envelope, encrypt it, and on the client side, you need to receive those small chunks, and you need to assemble them, and return the larger, original larger payload. Yeah, that's very that's hard. That's not very convenient to do. And for IoT security tunneling, it already have its own implementation of this message encoding and message decoding. All of this has been handled, so make our job much easier.
Perfect. Well, I mean, as Robert Table says in the comments, genius level stuff. So yeah, all of this is what you don't need to think about. And I think MQTT can be unbelievably complicated, and all of this communications, WebSockets can be complicated as well. So the fact that this is a checkbox and a remote invoke, I think, is where the magic all happens. Harold, we've sort of done this before. You had the Lambda debug toolkit, I think even a year or two ago when we spoke on Serverless Office Hours. So for people who have used that, what's new or what's different other than it's way more integrated into the Lambda service? and you don't have to do all the configuration steps yourself. Is there any sort of code or process changes that are different?
Yes, I remember last year in July in the AWS Hero Summit, we gave a demo of this prototype version of this. The difference is at that time it was really a prototype. The layers and the local paste are very rudimentary. It's actually bash files, and now the layers has been rewritten in Rust. And on the local side, there's proxy to the IoT tunnels. That proxy has been implemented using rewrite in TypeScript and embedded in the toolkit. All these efforts has made it much easier to and more performant and more secure to use this remote debugging.
Wow, so you just like casually throw out there that it's basically been rewritten, and it's not just Harold Sun's project that was quickly imported into Lambda. Although your genius, I think, is all over it. But yeah, this has been, it's not just a toolkit that's been imported into Lambda, but a lot of thought has been put into this to make it secure and to make it performant and do everything. So yeah, I love the journey. The question Jitnik 2006 asks, which I'm sure is very pertinent: do we get charged for debugging versions of Lambda invocations? So yeah, Shridar, I know you've done a bunch of work on this. So what's the story?
So you do get charged for the version. Think of that version, the debugging, as a normal execution, right? A function request that comes in. So if you have the debugger running and you, let's say, use a minute or two, then you'll be charged for that. But we thought about it long and hard, and instead of complicating the pricing model, we decided to keep it the way it is, because we do not believe that you would have millions of invocations for debugging alone, right? So all said and done, the cost added by this should not be any meaningful or significant. And what and you don't get charged for using the IoT, because that's wrapped under, again, the goal was to keep the pricing model very, very simple, not to have to introduce a new pricing model, keep it simple, easy to understand, and therefore we sort of made a way for us to not have to not be charged for the IoT stuff.
Okay, so yeah, no extra pricing dimensions, so no charge for the IoT, because I know IoT core charges whatever, I don't know what it is, but there is a normal charge component if you're using that elsewhere. So there's no charge for that, which is awesome. And then just the request charge will be the same because it's a request, and so it's just the additional duration charge. So if you do have a Lambda function that takes 1 second to run, and you then run that debug for, I don't know, a minute, you then paying for a minute's Lambda invocation time, rather than 1 second or 10 seconds. But I mean, even within the Lambda,
I think Julian's voice is cutting out there, but I think.
Oh, sorry about that. Am I disconnected?
Sorry. You want to say the last few sentences again, Julian?
Well, I was just saying that. So the duration, the only difference, no charge for the IoT. Just to reiterate what you said, a normal request charge, and then if your Lambda function was 1 second, and now you're going to spend 1 minute doing debugging, or I don't know, even 10 minutes doing debugging, that's literally the only additional duration charge will be longer. But as you said, you're not going to be running millions of these. I don't know, you're going to be doing 10, or even if you're doing 100, I think that marginal cost is going to be absolute fractions of pennies for a single Lambda function, possibly even within the free tier if you're in a development account. So, not something to really worry about, I think, is the message. Cool. So, what else should people know about this? I mean, is there anything that we missed out, or anything that we haven't spoken about yet?
No, we just want to hear from folks. And by the way, the feedback so far, we have received a ton of, there's been a ton of feedback coming in, and it has been great. It has been great to see. It is always great to see that people are finding value in it. So remote debugging has been overwhelmingly, the reactions have been overwhelmingly positive. But if there are things that you want us to look at, improve, make better, add to it, absolutely reach out to us, and we'll definitely take a look at it. In general, any feedback is welcome, and other than that, let us know what else you'd want us to focus on, pay attention to, be it for local debugging or in general for any of your development needs.
Okay. Yes. Thanks, Shridar. Two questions I sort of had. I'm thinking of a use case, in the cloud, maybe you've got a Lambda function that processes something from SQS, for example. So there's sort of a trigger behind the scenes. You're not quite sending a payload. If you were going to debug that remote Lambda function, how should people think about that? Because the SQS message is going to be there sent to Lambda. It's not going to obviously land in this version. Even though we're saying we live debugging in the cloud. This is really about connecting your local machine to send a payload to a Lambda function rather than just, enabling remote debugging in the cloud. And I use SQS as an example, but it could be something behind API gateway. If you turn on remote debugging and then send a curl request to your API gateway, that's not really going to work, is it, to have your local breakpoint just magically appear?
Right. Yeah. That's not how we've designed it. But you are able to achieve those same goals. If you wanna think of it as emulating, all you have to do is drop in the payload that you receive from via the SQS event source, via the SQS ESM. But not precisely that, right? Where you just attach a debugger and every time there's an invocation, because that's the thing that we sort of stop short of, because you don't want to overreach into the intent. You don't want to tap in the way of functions that are actually running in the cloud, and so we wanted this to be very intentional, so that when you're debugging versus you suddenly start receiving a burst of requests and all of them go somewhere because there's some debugger configured against it.
Yeah, no, exactly. There's a potential for things to go wrong. And also remember, with AWS Toolkit, it's much easier, even in that local debug and the remote debug config, to generate test events. And also, you can, if you have a test event in the console that you've used, you can also grab that locally. The test events, far easier to generate, far easier to grab from the cloud. And always, I don't want to say worst case scenario, but you could even, you're debugging, you're testing, log a single event, copy that out, and off you go. Cool, excellent. We've got a minute or so left. Anything else to think about? Any best practices? Any ideas, tips, tricks? Anything people should be thinking about? Or just go build, play, enjoy your debugging, and hopefully your life with Lambda is that little bit easier.
Yeah, I think we covered the best practices, and we have been very careful to build the guardrails in the product itself. The timeout and adding and removing the version. So we've taken care of a lot of the best practices and built them as guardrails within the product itself. But again, just the word of caution that do not think of this as we would recommend against running this in production. Why would you run this in production anyway? But unless you're super curious, just don't run it in production. Use debugging for what it is meant for. That is to debug in some debug test or local environment. I think apart from that, go have fun. There's a lot to do with this.
Cool. And one question, if they push back from security teams, or what, you're creating a connection between me and my Lambda functions running in my lovely secure VPC. Any words of advice to help people understand what's going on here? Or I can understand there'll be some organizations who wouldn't want this kind of thing to happen, but how would you start that conversation with a team like that?
Yeah, I think other than the IoT permission, we're not introducing any surface area, any other vector that could open you up to vulnerabilities, if you think about it. Because if you have update permissions, if a user has update permission, they could pretty much do all of these today. Yeah. The only net new thing is the IoT permission, and if your org does not have that, that's a separate conversation. Then you need to have that conversation. But in otherwise, this is adding a layer. If you have an update permission, you could go add any layer, and you could potentially do things like this even today. Even without remote debugging capability.
Yeah, so ultimately you're updating your code. Yes, you've got a tunnel, but you can't copy things from that tunnel or upload things from that tunnel yourself. That's securely managed client to server, and you can just update your code, which you can do anyway today. So.
Yeah.
Excellent. Well, Shridar, a pleasure as always. Harold, a pleasure as always. I love the deep, as Robert Table says, genius level stuff that has been built into this. More stuff just being built into the Lambda product to make it more easier to use. So, thank you very much for spending time in Serverless office hours.
Thank you. Thanks for having us. Bye-bye, everyone.
See you next week. I'll be away, but we'll have a great show next week talking about depot.dev on CI/CD. Bye-bye, everybody.
Thank you.